Welcome to Chapter 9. We're actually going back to Chapter 9 now. And we're going to talk about conic sections in Chapter 9. We're going to kind of dance around between the sun here, looks like, for a little bit with this lesson, but that's okay. We're going to deal with conic sections in Chapter 9. So I'm going to start out by giving a brief definition of what conic sections are, but a main focus of our conversations today is going to be going kind of back to that parabola, and we've talked about a parabola already. But we're going to go a little bit more in depth with a parabola about how we find a couple different parts that we call the focus and the directrix, and how we go about writing equations of parabolas, and giving a little bit different information than maybe we've been given in the past. So first discussion here needs to be talked about conic sections. These are the different conic sections that we are going to look at in this chapter. We're going to start out today with a parabola. And then we'll look at circles, ellipses, and hyperbolas. But a conic section is just a curved form by the intersection of planes of double cones. So a parabola, you know what parabolas look like. If you take a cone and cut it, you're going to get a parabola that's going to, there's a parabola, there's a parabola, there's a parabola, different types of parabolas that we've talked about already. And like I said, we found the axis of symmetry, and we've wrote equations for these. But we're going to concentrate on a couple other parts in this one. We're going to talk about circles, more in depth about circles, how we go about writing equations of circles, and those different types of things. We'll talk about ellipses. Ellipses is kind of, I'm a track guy, so it kind of looks like a track. That's what an ellipse is. And then we're going to talk about the last one, which we're going to talk about is what we call hyperbolas. And we're going to look at writing equations for hyperbolas. So hyperbolas, are essentially going to be kind of parabolish-like looking things, but kind of doubled up. And we're going to look at these in different forms, and it talks about the form, generally speaking, that we're going to, some of them, that's kind of the general form of a second degree equation, and we're actually going to take that ax squared plus bxy plus cy squared, blah, blah, blah. We're going to actually take that towards the end of this unit and figure out which one of these exactly they're talking about by putting in different values for a's and b's and c's and so on. So let's take a look specifically then at the parabola. So if we look at a parabola, and we've talked about a parabola already, we said the parabola was anything that's in the form y equals a times x minus h squared plus k, where h and the k was our vertex. So if I was going to go ahead and draw a parabola in here, okay, so there's my parabola, maybe a bad parabola, but whatever. So we've got this vertex here. We called that the vertex, and that was our hk value. So we were able to find that vertex. The other thing that we talked quite a bit about was we talked about this axis of symmetry line. So if we took the kind of this vertical line down and we went through the vertex, we called that our axis of symmetry line, and we just kind of labeled it the AOS. That was that axis of symmetry line. It was kind of that x is equal to lines. And those are really the two things that we concentrated on as far as making them. And then we did talk about, going ahead and graphing them. And we kind of talked about this equidistance concept that, okay, if I had a point kind of on here, if I picked a point right here, that this distance here and this distance here, that those two pieces are going to be constant. Those two pieces are going to be equal to each other. And that's kind of how we helped graph this line. But kind of a unique thing happens when I do that, and especially a specific point. There's a point right here inside of a parabola, and this doesn't move, okay? We picked a point, and I just picked a point and drew that, but keep in mind, this point doesn't move. We can draw a bunch of different things as far as what I just did, but there's a certain point inside of every single parabola, and it's not just parabolas, it happens in ellipses, and it happens in hyperbolas, and actually it happens in circles too, where everything kind of focuses. And that point right there is what we call the focus. The focus is kind of this point inside of a parabola where, if you think about sound waves or beams of light bouncing off, kind of half and half in here, bouncing off this And I'll put these in a light green. But if I take a ray of light and I go it down there, this focus point is going to be the point where all of these different light beams bounce off to and go back to. Okay, that's what we call the focus point of this. It's where everything focuses in. And you've seen this with satellites or sound waves, or like microphones, where they've got kind of that microphone in the middle, because that's where all the sound is kind of bouncing off to. That point is called the focus point. It's kind of where everything is focusing kind of in on. And I'm going to get rid of those because they just get in my way, but I think you kind of understand. Now, the unique thing that happens with that focus point is if I draw kind of this in here that I have in here, and essentially you would have a beam of light coming down there and bouncing off this direction and bouncing off that direction. What actually happens is, these two pieces, like I said before, those two pieces are going to be congruent to each other. But what also happens is, and it doesn't matter where I draw those different lines, if you draw a vertical line from the point where that hits the parabola, this distance here and this distance here is going to be the same. This distance here and this distance here are going to be the same. If I drew another one in here and I said, okay, we're bouncing off there and we're going up to there, this distance right here is actually going to be equal to this distance right here. And if you kind of see what's happened, and I kind of tried to make it look like this is what happens anyway, but a line, really all of these points here, here, and here, they go on this kind of same line right here. And this line right here has a name to it, and it's what we call the directrix. Okay, this line here is called the directrix. And that line itself is equidistance from the point on the parabola to the focus, and from that point on the parabola to that line. Those pieces are going to be congruent to each other. So I've got a really kind of a bad drawing here. Maybe if I drop this down a little bit, it'll be a little bit better. I'll drop it down underneath, and you'll see why I have to do this in a second. But I'm going to extend these just a little bit, make them a little bit longer. Because what happens then is this part right here, that distance right here, is from the focus to the vertex. So this distance is going to make a difference as well. And these two distances are going to be congruent to each other as well. And we're going to give them a name, and we're going to call those C. And that C value is going to become important here in just a minute. So this parabola is made up of a whole bunch of different parts. We've got the parabola itself. We've got that axis of symmetry. But we also have what we call a focus. And we have what we call a line of directrix. And the unique thing about the focus and the line of directrix is the focus and the line of directrix are the exact same distance from the vertices when we're talking about these different parabolas. So the form we used in general terms before was y is equal to a times x minus h squared plus k. And again, we didn't talk much about that a value. We talked about the rest of it, but we want to be able to talk about that a value as well. So in general terms, here's what we have. It's a little bit better drawing. Okay, and I'm going to briefly talk about it. It's not a bad thing to kind of get all of this down. So you can just press pause at some point if you want to write it all down. But essentially an equation of a parabola, we've got two equations of parabolas that we could have. We can have parabolas that go up and down, and we can have parabolas that go left and right. And our main goal today is to be able to write the equations of these different parabolas. So with that being said, if it goes up and down, it's in the form y equals a times x minus h squared plus k. Now that a value is actually equal to, a is equal to 1 over 4 times c. And there's a way to prove that, and we're not going to go through the proof of that a value comes from distance formulas and all of this different kind of stuff. And if you're interested in that, you can certainly look it up. But we're just going to generally use the terms, how do we go about finding that a term? A is always going to be the value 1 over 4c. What's c? C is the distance from the focus to the vertex, or from the directrix to the vertex. That's always going to be kind of the same. Well, what's the vertex? We've always said the vertex is hk. So that's our value for our vertex, it's hk. How do you go about finding the focus? The focus is always going to be your h value, and then your k value plus c if it's going in this direction, because that's our y value that goes up and down. What's the directrix? The directrix is a line. In this case, it's going to be the line y equals k minus c. Other things to keep in mind, remember that when a is greater than 0, it goes up, it's positive. If a is less than 0, it goes down. And we've talked about those things. So that's kind of the general form of a parabola if it goes up and down. And again, pause if you need to pause. The other type that we could have is we could have a parabola that opens to the left or opens to the right. I think I did that backwards, but whatever. In that form, our equation for a parabola is x is equal to a times y minus k squared plus h. Notice the k and the h they flip around kind of. Now, understand, there's other ways to write this equation. This is just the way that we write it, or I write it. You could move the h to the other side. There's other things you can do to this as well. The a value is still the same. It's 1 over 4c. Again, that c value is from the focus to the vertex, or the vertex to the directrix. The focus in this case now is going to be h plus c, because we're going left and right, and k, and the directrix is going to be an x is equal to. And if a is greater than 0, it opens to the right. If a is less than 0, it's going to open to the left. Again, if you want to get this into your notes, press pause at this point, and when you've got this all copied down, you can go ahead and do what you need to do. So what do we want to be able to do with this? Well, what we want to be able to do with this is we want to be able to be given different pieces and be able to write the equation. So for example, let's say that I give you a focus. And I give you a focus that's 4, 0. And I give you a directrix that is x is equal to -4. We want to be able to write the equation of this. So we want to be able to write the equation. Okay, so we either want to write y is equal to a times x minus h squared plus k, or x is equal to a times x minus k squared plus h. We want to be able to write it in that form. So the first thing I like to do when I'm doing these is I like to go ahead and I like to graph it, because visually, I'm a visual person. So I like to see things visually. Okay, so there's my x, y coordinate. My focus is at 4, 0. So 4, 0 is right there, and I'm just going to put an F by that so I know that it's my focus. It tells me my line of directrix is x is equal to -4. X equals our vertical lines. Okay. So there's my directrix. X is equal to -4. Okay, well, in order to write the equation of this, there's certain things I have to know. I need to know the vertex. If I don't know the vertex, I can't fill in my h and k values. So I have to know my vertex. I need to know the h and k value. And also, we're taking this one step further. We're going to find this a value as well. So we said the a value is going to be 1 over 4 times c. So I have to figure out what those two things are. Well, we talked about how do we find what's the distance from the focus to the vertex and the vertex to the directrix? Well, we said that those two distances were equal to each other. So doesn't that mean that if I find the midpoint of my directrix and my focus, don't I have the vertex? Yeah, I do. So I've got, this is essentially the point negative 4, 0. This is the point 4, 0. What's the middle of those? Well, 0, 0. So my vertex, I'm going to put a little V there, that's my vertex. I know my vertex is kind of in the middle because we said that those two pieces have to be the same. We also said, and since I'm there right now, we also said that that was our C distance. The distance from the line of directrix to the vertices or the vertices to the focus, that was our C value. So we know that distance now. That distance is going to be 4. Okay, now we have, next thing we have to figure out then is we need to figure out which way this opens. Okay, we know the vertex. We can find the A value here in just a second. But which way does this open? Does it open up, down, left, or right? And that's kind of why it's so important to draw it. Because now that we've drawn it, we talked about that focus kind of a few slides back and said that the focus was always in the middle. Not in the middle, but inside of the parabola. So our focus is right here. My vertex is right here. The only way that this can go is that it has to go something like that. So this is an x is equal. How do I know it's x is equal to? Well, I always kind of say because this part of it looks like an x, kind of, whatever. It doesn't go up and down. That looks like a y. It kind of looks like an x. So it looks like an x, so I know this is going to be an x is equal to. So this is going to be x is equal to a times x minus k times y minus k. That's a nice y, by the way, up there. That's a y. Y minus k squared plus h. Well, we know our vertex. Our vertex is at 0, 0. We didn't put that, but it's at 0, 0. So there's our vertex. But now we got to find that A value. Well, A is 1 over 4C. We said the C value was 4. So A is going to equal 1 over 4 times 4, which is 1 over 16. So if I can write the equation of this line now, my A value is 1 over 16 times Y minus my K value, which is the Y value, and there isn't one. So it'd be Y minus 0 squared plus my H value, which is 0, so that'd just be plus 0. You could leave it like that, or you could rewrite it as y is equal to, x is equal to 1/16 times y squared. That's the same exact thing. Okay. So now we've gone ahead and we've written the equation of that parabola just given the focus and the directrix. And that's really what our goal is today, is to be able to be given different forms and to be able to do this. Okay, let's look at another example. This time I'm going to give you the vertex. The vertex is at 0, 0. And our focus is going to be at 0 and negative 0.5. We're going to write the equation. That's going to be our whole goal today, is to be able to write the equations of the line, or at least this lesson. You're actually getting 2 lessons today to do over the next several days. Anyway, so the equation of the line. So again, I'm going to draw it first because the drawing just helps me get a look at it, kind of helps me focus on what focus on what it's going to look like, give me the direction that it's going to open. So my vertex is at 0, 0. So there's my vertex, 0, 0. So the equation itself, okay, got the h and the k value already. We need to know the vertex, and we need to know the a value. It says the focus is at 0, negative 0.5, and I'm going to exaggerate it a little bit. So our focus is going to be 0 and negative 0.5. So there's my focus. So that means my line of directrix is going to be up here. And why do I need the line of directrix? It just kind of helps me figure out, where it's going to open. So my line of directrix is going to be that line right there. And I think that's probably the line y is equal to, well, we know this distance. This distance is 0.5, so this distance has to be 0.5. So y is equal to 0.5. That's my line of directrix. Don't necessarily need to know that, but it doesn't hurt us. So now I'm going to figure out where does this go? I want to give a quick sketch of this. So it always opens towards our vertex, or toward the vertex towards, and focuses in the middle, inside, stupid terminology. So it's going to go like this. Okay, so is that an x equals or is that a y equals? Well, that's a y equals. So we're going to use the form y is equal to a times x minus h squared plus k. We need to find our a value. So our a value is going to be 1 over 4c. That's what it's always going to be. Our c value in this case is 0.5, but it's going down, so it's going to be negative. Okay, so we're going to go 1 over 4 times negative 0.5, which is 2. So our a value is negative 1/2. So our equation then is going to be y is equal to 1/2 x minus 0 squared, so just x squared, plus k, which is 0. And there it is. There's the equation of our parabola with a vertex of 0, 0, and a focus of 0 and negative 5. Okay? Let's look at another one. In this one, we're given a directrix line, y equals 4, and we're given the vertex 3, 2. And we're going to write the equation. So if I'm looking at it going, okay, how is this going to open? It's got to go through the vertex. My line of directrix is up there. That means my focus must be down here somewhere. So let's find the focus. So we can figure out what this distance is. This distance is going to be 2, right? Because we went from 2 to 4. So I'm going to go down 2 to get to my focus. So this is going to be the 0.30. So this is going to be my focus. Okay, because we know that distance has to be the same. So my graph is going to look something like this. So x equals or y equals? Well, y equals. So this is going to be y equals a times x minus h squared plus k. So we have to find the a value. A value is 1 over 4c. C value is 2, but it's going down, so it's going to be negative. So that's 1 times 4 times negative 2, which is negative 1/8. So I've got my a value. I've got my vertex. That's all we really need. So we've got y is equal to negative 1/8 times x minus, my h value is 3, so x minus 3 squared, plus my k value, which is 2. And there's your solution. And you're done. Okay. One more. So in this case, we've got a focus that's at 0, negative 2, and we've got a directrix at x is equal to 3. Okay, so I'm going to go ahead and sketch it first. Focus is at 0, negative 2. That's right there. So that is my focus. My directrix is that x is equal to 3, and I'm going to exaggerate this. X is equal to 3 is a vertical line. I'm going to exaggerate it here a little bit. Okay, so this is x is equal to 3. This was the point. I'm just going to put it here to kind of help myself out. Okay, so that's my focus. That's my directrix. Let's move this down a little bit because it's in the way. So I know that my vertex is the midpoint of my focus and my vertex, or my focus and my directrix. So I'm just going to draw this line in here, and that midpoint right there is going to be where my vertex is going to be, and my focus is over there, so I know my graph is going to look something like that. So this is going to be an x is equal to, so I'm just going to write what it's going to be. So x is equal to a times y minus k squared plus h. We have to find that vertices. So I know the vertices is halfway between there. So this distance has to be 1.5 and this distance has to be 1.5 because they're 3 apart. So in the middle is 1.5. So the vertices, that point right there is going to be 1.5 and -2. So I've got my vertices. I need my a value. A is going to be 1 over 4c. So a is going to be 1 over 4. My c value is 1.5. Notice which way this is opening. It's opening in that direction. So since it's opening in that direction, it's going to be negative. So we have to take it times negative. So 1 over, so 4 times 1.5, it's -6. So -1/6 is my a value. So my equation then, so I've got my a value, I've got my vertex. I've got to be a little careful with this when you do this. So we've got x is equal to my a value, which was -1/6, times y minus my k value. Well, remember our vertex is hk. My k value is -2, so this would be y minus -2, so this would be +2 squared plus my h value, which is 1.5. And there's the equation of that parabola. Okay. So that's today's part of the lesson. We're going to go to another level of this, and we're going to kind of go the opposite direction in the next lesson. That you get to it when you get to it, but it's over the next couple days, where you're actually given the equation, and we're going to find the focus, we're going to find the directrix, and we're going to find all of those different types of things. So we've went one way, we're going to go the other way in the next lesson.